Hello. Today we're going to take a look at how to use trigonometric functions, sine, cosine, and tangent, to find all the angles and sides in a right triangle when you have been given a few pieces of information. If you are unfamiliar with sine, cosine, and tangent, pause here and go take a look at this introductory video that shows you what those functions mean and how to use them. First thing to notice is we have a right angle in this triangle. The ratios of SOHCAHTOA only work in right triangles. There's a whole other set of formulas, the law of sines and the law of cosines, which you will encounter later for if you're not in a right triangle. But the first thing you need to know is that these ratios work in right triangles. All right, so the next thing we're going to check is this little mark here means degrees. So as I go to use my calculator, I'm going to go to mode here, and I'm going to check and make sure that degree is highlighted in this case. And if your problem is in radians, then you would just go down and press enter on radians, and now you get your answer in radians. But I'm going to go back to degrees and press enter, and then I'm going to get out of mode. All right, so the first thing I do every time I have a triangle trig problem is I write SOHCAHTOA on the page. Again, if this doesn't mean anything to you, go and check out my video on SOHCAHTOA. Next, I'm going to decide which I'm solving for. I'm going to solve for x first, and my angle is 32. So I ask myself, x is which of my three sides? Is it my opposite, adjacent, or hypotenuse? Well, 6 is across from the right angle, so that is my hypotenuse. And x is the other side that makes up 32. That makes it my adjacent. And if I have adjacent and hypotenuse, then I'm in the ca syllable or cosine. And now I'm ready to write my little equation. The cosine of 32 degrees equals my adjacent x over my hypotenuse 6. And since x is what I want to solve for, I would multiply both sides of the equation by 6. And then if I'm working with my TI calculator, I can punch that right in just like that. 6 times the cosine of 32 degrees, close my parentheses, and I get my answer. And if I'm working with my iPhone, check out this video on how to use those function keys in your iPhone. But rounding to my nearest hundredth, that's 5.09. Now, to solve for my y, I have two choices. I now have two sides in a right triangle. I could use Pythagorean theorem, or since this is a video about trigonometry, I'm going to go ahead and use my trig function. So again, I ask myself, y is which of my three sides in relation to 32? It is the opposite. So opposite and hypotenuse. By the way, if I have a choice, I always work with the side that is given rather than the side I found, so that in case I made an error, I don't continue that error forward. Just a little hack. Okay, so I'm going to set it up O and H. That's my sine syllable. So this time sine of 32 equals y over 6. Again, I'm going to multiply my 6 to both sides and get 6 sine 32 equals y. And now I'm going to put it in my calculator. 6 sine 32, and I get that answer. And if I want to check, I could go ahead and do Pythagorean theorem. And if you aren't familiar with Pythagorean theorem, then take a look at this video. But here we go. So I've got 5.09 squared plus 3.18 squared, and that is awfully close to 6 squared. All right, next problem. In this problem, again, I note I have a right angle, and this time I'm given sides, and I'm asked to find angles. The first thing I do always, write SOHCAHTOA on the page. All right, now I need to figure out what these sides are in relation to my angles. So here's my x angle. The 4 is the opposite. This is my hypotenuse because it's across from the right angle, which means the 3 is my, that's right, adjacent. And if I have O and A, I'm looking at the tangent syllable. So now I write my sentence. Tangent of x equals opposite over adjacent, right? Tangent opposite over adjacent. Okay, now this is where I use my tan inverse function, right? I have the tangent of some angle x is 4/3. My tan inverse says the angle whose tangent is. So I want to know the angle whose tangent is 4/3. So that's how this equation becomes this equation. And now I use my calculator. So I'm going to go to my second function. I'm going to press my tangent because that gets me to my tan inverse of 4/3, and that's my degree measure. So 53.13. And now again, I have two choices. Any triangle has 180 degrees. So if I know 90 and I know 53.13, then I know my y by doing that, 36.87. But since this is a trigonometry video, let's set it up and do it again. So this time, I'm looking at it from my y perspective. So from my y, well, this is still the hypotenuse, but this time 3 is my opposite, which makes 4 my adjacent. And so the tangent of y, opposite over adjacent, 3/4. And now I ask myself the angle whose tangent is 3/4. And I go back to my calculator. I call up my tan inverse key, put in my 3/4, and I get my answer. Okay. And so I see that whether I do it by subtracting from 180 or I do it by using trig, I get the same answer. One more problem, the trickiest one. All right, so here we go. We have been given two right triangles that are connected by a shared side, and we know the value of that side. And then we have one angle in each of these triangles. That's all we need to find everything else. First thing, let's go ahead and find the missing angles in the two triangles. So if I'm looking at this triangle, if this is 20 degrees, so this is 90, which means these two make up the other half of 180, 90, which means this is not drawn to scale in any way, but this is 70 degrees. And then same thing, if this is 40, forgive my handwriting, then this guy, again, we're splitting the 90 that's left, that would be 50 degrees. All right, now we've solved for all our angles. So now let's go ahead and solve for our sides. I'm going to call this side X, and now I get to pick an angle. I could use either angle. So let's say I'm going to use the 70. So I ask myself, what is my X in relation to my 70? And then what is my 8 in relation to my 70? Because 8 is the side I have. And as always, I'm going to put my helpful SOHCAHTOA on the page. This is my hypotenuse. So 8 in this case with 70 is my adjacent, and X is my opposite. So OA, I'm working with my tan function. So I write my sentence. Tangent of 70 equals X over 8. 8 tan 70 equals 21.98 when I round. I'm laughing at how not to scale my drawing is. Okay, and again, now I have my options. I could do Pythagorean theorem, or I can solve for this using the stuff I've got. So maybe I'm going to call this variable y, and I'm going to say, okay, I'll keep working with my 70. So y is my hypotenuse, and 8 is my adjacent. So adjacent and hypotenuse, that's my syllable. So cosine of 70 equals 8/y. All right, this time my y is on the bottom, but that's okay because I know algebra. So I'm going to multiply both sides by y, and now I'm going to divide both sides by cosine 70. And now I'm going to use my calculator. And I'm going to find out that my hypotenuse is 23.39. And if I want to make sure that I'm right, I could quickly go ahead and do my Pythagorean theorem. So that tells me that 8 squared plus 21.98 squared equals that number. And if I did it right, then that should be 23.39 squared. And there we go. And of course, these are off slightly because these are approximations, right? I rounded, but this is close enough. All right, excellent. Now let's solve the rest of it. So now I need to go into this triangle. I'm going to call these sides P and Q, and in relation to my 50-degree angle, P is my opposite and 8 is the adjacent, and opposite over adjacent puts me working with my tangent function. Tangent of 50 equals P over 8. 8 tan 50 equals P. Calculator, 8 times the tangent of 50 degrees tells me that that's 9.53. And finally, I'm going to solve for Q. Well, in relation to 50, my Q is the hypotenuse. my 8 is still the adjacent. Adjacent over hypotenuse tells me we're working with the cosine function. Cosine of 50 is 8 over q. Multiply by q, divide by cosine 50. Q equals 8 over cos 50. 8 divided by cosine of 50 gets us 12.45. And a quick check with my Pythagorean theorem, 8 squared plus 9.53 squared equals that. And those are pretty close. If I round this, I get that. Alrighty, so that is how to use SOHCAHTOA when you are given right triangles and bits of information to find all the rest of the information. All right, check out these other videos. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.